This is video 3 of 3, chapter 5, section 5, indirect proofs and inequalities in one triangle. Triangles, as you know, are made up of 3 sides, but not all 3 sides will work. If 2 of the sides are too short, they won't be able to create a triangle because they won't be able to meet at the top. This helps us with the triangle inequalities theorem. The triangle inequality theorem explains what types of triangles are allowed to be created. So if I have AB plus BC, that has to add up to more than the third side, which is AC. Otherwise, your triangle won't be able to close. And that works for all 3 sides, or all 3 groups of sides. I have BC plus AC. It has to add up more than AB. And the very last one, AC plus AB has to add up to more than BC. You're going to use that theorem to answer the next questions. It's yellow paper again because I ran out of white. It says, tell whether the triangle can have the sides with the given lengths, and you need to explain. So any 2 pairs of sides should add up to more than the third. So if I have 7 plus 10, that should be greater than 19. 7 plus 10 is 17. That should be greater than 19. 17 is not greater than 19. So that means that this triangle will not work. And the reason why is because it doesn't work with the triangle inequalities theorem. Alright, your second example in this section says tell whether the triangle can have the sides with the given lengths, and you need to explain. Same thing. I need 2 sides to add up to more than the third. So I should have 2.3 plus 3.1 should be greater than 4.6. 2.3 plus 3.1 gives me 5.4, which is greater than 4.6, so that one works. And 2.3, 3.1, I'll add 3.1 and 4.6 plus 4.6 should add up to something that's greater than the third side, which is 2.3. 3.1 plus 4.6 is 7.7, which is greater than 2.3, so that one also works. And my last 2 are going to be the 2 outside. So 2.3 plus 3.1. 2.3, oh no, I already did that one. Let's look. 2.3 and 4.6. 2.3 plus 4.6 should add up to something that's bigger than 3.1. 2.3 plus 4.6 is 6.9, and that is bigger than 3.1. So that third section of the third grouping of numbers also works, which means that this triangle can be created with these 3 sides. Third question, you need to tell whether a triangle can have the sides with the given lengths. First, we need to figure out what the lengths are. They give us 3 expressions, and they give us a value to substitute for the letter n. So first, we're going to have to evaluate each one. I have n plus 6, which is 4 plus 6, gives us 10. 10 is our first side length. I have n squared minus 1, which is 4 squared minus 1. 4 squared take away 1 gives us 15. That's another side length. And then I have 3n, which is 3 times 4, which is 12. And that's our third side. Now we're going to have to apply the triangle inequalities theorem to see if this works. And if you want to pause the video right now and try it for yourself, I think that's a great idea. Here we go. We've got side lengths were 10, 15, and 12. I'm going to add 2 of the numbers together, and it should add up to more than the third. 10 plus 15 should be greater than 12. 10 and 15 is 25, which is bigger than 12, so that one works. 10 plus 12, so my 2 outside numbers should be bigger than the middle one. 10 and 12 is 22, which is bigger than 15, so that one works. I have 10 and 15, 10 and 12, so now I need 15 and 12. 15 plus 12 should be larger than 10. 15 and 12 is 27. which is bigger than 10, so that also works. So we can say that yes, this triangle can be created because each of the pairs of sides is larger when you add them together than the third side. Okay, last problem. This one gives the third side as an unknown. So we have two side lengths. One is 8, one is 13, and we don't know what the third side is, but they want us to find a possible range. We're going to treat this just like a number, and we're going to use the same theorem. So I have 8 plus 13 should be larger than x. We have 13 plus x should be larger than 8. And we have 8 plus x should be larger than 13. 13 plus x gives us 21. So x is smaller than 21. I'm going to actually flip that over. X is less than 21. 13 plus x is greater than 8. I'm going to have to subtract the 13 from both sides, so I'll get x is greater than negative 5. And then here I'm going to have to solve for x again. I'm going to have to minus 8 from both sides, and I'll get x is greater than 5. Now if x is bigger than negative 5 and x is bigger than positive 5, this one doesn't need to be included because it's implied. If x's number is larger than 5, then it's obviously going to be numbers that are bigger than negative 5. So we don't have to worry about that one. This one and this one, however, we need to combine so that we have all the possible answers. X has to be numbers that are greater than 5 and less than 21. So we're going to stick the x in the middle. X has to be numbers that are less than 20, whoops, I don't know why I was going to put 22 there. Less than 21, and it also has to be numbers that are bigger than 5. And this is our range of values that we can have. Again, if you had any trouble with any of the videos, please go back and watch them. Now you're ready to write your summary. You're going to be ready to take your quiz, and if you have any additional questions, please put them at the bottom of your notes so that you can remember and ask me what those questions are on Monday.